Hello there, and welcome to this 6G World webinar, What's Stopping a Network of Networks Working in Practice? I'm Alex Lawrence. I'm the managing editor at 6G World, which is a news site dedicated to all kinds of content, exploring what comes after 5G and how we get there in a way that makes sense for the industry and its customers. If you haven't already, then please do consider signing up to our newsletter on 6gworld.com, and you'll get the top stories into your inbox every 2 weeks, with the next one being delivered on Thursday this week. So, to the point in hand, in the last few months, we've seen some really exciting advancements in the thinking about future networks and their value. In November, the ITU put out a description about 6G, which involves it being much more efficient and sustainable, both environmentally and cost-wise. In February, governments worldwide called for open, resilient networks to enable citizens to access services wherever they need them. Both these demands don't say it explicitly, but they would tend to rely on a concept that's been bandied around for a while, this network of networks to enable access where and as you need it. And in fact, at Mobile World Congress, there was a demo from the UK's Project Reason, which showcased several high-definition cameras which were uploading 3D images in real time over a combination of Wi-Fi, Li-Fi, and 5G, showcasing what can be done with existing technologies together in a way that can't be done individually. So in that example, we're looking at creating fresh opportunities to enable things that we can't do today. Even last spring in the 6G symposium there, we had operators like Vodafone and Liberty Global suggesting that maybe the real value in a future generation of telecoms wouldn't be in much greater speeds and feeds, but in a sort of radically more accessible set of services, and that coverage might be the killer app for 6G, which sounds very exciting, obviously. The question is, if that's so good, why aren't we already doing that? I mean, it's not like the telecoms industry is unfamiliar with network effects, and the idea of being able to sort of build out and for more impactful services. Clearly not so straightforward, and this is an area where I would struggle, but happily I have three experts with me who've been looking at the industry and its evolution from some very different perspectives. So I'd like to welcome Paul Harris, the Principal Wireless Architect from Viavi Solutions CTO office. Fanny Parzis, an R&D engineer with Orange and 6G NTN, and also Dimitris Mavrakis, the Senior Research Director at ABI Research. I'd like to make sure the webinar is helping you out there in the audience. So while I have questions and points that I'd like to touch upon, please do add in your questions and comments in the box provided as well. Those will come to me, and I'll do my best to weave those in as we go. But I will also include some time for questions in the second part of the hour. As with all 6G World webinars, you should be able to find the recordings of this webinar along with previous ones and videos and custom research on our newly revamped 6G World website in the next few days. So with that, let's dive in with some quick introductions from each of the panelists. And as a bit of context, I'll ask each of you to give us an idea of who you are and what a network of networks actually means to you. So Paul, perhaps I can start with you.
Sure, thanks, Alex. Hello everyone. My name's Paul Harris, as Alex mentioned, work within the CTO office of Viavi Solutions. And at Viavi, if you're not familiar, we're involved in all things kind of end-to-end test and optimization across networks from fiber through to wireless and O-RAN and all the pieces in between. So network and networks, as Alex mentioned, has been an increasing topic of interest. And it gets more interesting, obviously, the more we consider some of the new technologies now entering the arena. So yeah, some initial thoughts from my side, I guess. I think, we've seen and made some steps forward with interworking when we look at 5G NR and wireless LAN over kind of recent years. Integration of NTN adds another dimension to this. Whereas for 5G NR, it's kind of been a bit of a bolt on. I think that is one technology that we could see greater unification in the development of 6G specifications from the beginning, which could aid with some of this sort of bridging between terrestrial and non-terrestrial. However, even with a cellular standard like 5G NR, if we just consider terrestrial, we've got the interworking of private and public networks to consider as well. So I think there are many ways you can frame kind of network of networks even within a standard and not just necessarily between standards. But also I think it's important to maybe step back and question as well which networks truly need to be interlinked and what the benefits are for doing this. How far do we need to go? Which markets and use cases can really benefit from it? Which users are going to see a benefit from having it over, say, having more disjoint networks in terms of the level of integration, but maybe the applications can still work well enough on top of that. And yeah, I think, from our perspective, Viavi, our main interest and focus is ensuring with any of these types of systems that we're ensuring it's robust and performant as well. And kind of that means not just ensuring conformance to the specifications, so for HTTP or anything like that. It's also going beyond that to emulate and really stress test the key types of scenarios that are focused on the end user to meet those application requirements. So yeah, I think I'll leave it there. That's a little bit of an overview and some initial thoughts from my side. Thank you.
Great, thanks, Paul. I'm glad that you mentioned that interworking piece, and so that actually may be a very good opportunity to invite Fanny to give an introduction of where you're coming from on this.
Yeah, good afternoon, everybody, and thanks a lot, Alex, for inviting me to this webinar. Well, this is a very huge topic, and I will approach it from the perspective of integrated terrestrial and non-terrestrial networks. So my name is Fanny Parzis. I'm a research engineer at Orange Innovation, and I've been leading R&D activities on connected drones for quite some years now. And more recently, I've moved to satellites communication, mainly through the two European projects, 5G Stardust and 6G NTN. So please note that first of all, I will talk as a research engineer, so with my own perceptions of challenges. So what is being done within Orange Innovation has not to be considered as any commitment with respect to Orange wholesale or Orange business. So what is a network of network? And well, this is a huge topic, and really this is not an empty world, because even from the side of satellite technologies only, there is already a lot of things which could be covered. It could be about 30-year-old services, future systems, 3GPP and not 3GPP, IoT, broadband for uncovered rural areas, continuity service for planes, cars, boats, and also direct access to mobile smartphone. As far as I'm concerned, I will focus much more on the direct-to-cell scenarios in the 3GPP vision. Well, this is maybe only part of the answer, and maybe somebody else will highlight different aspects, but well, we have to limit ourselves. Maybe, Alex, could you show the slide that I gave you? Thank you. So this slide is really to give you a bit of vocabulary, especially for those who are not familiar to the topic. So what is for me a network of network, also called sometimes integrated terrestrial and non-terrestrial networks, or even sometimes 3D, three-dimension multi-layered networks. Well, this is networks composed of different layers of terrestrial infrastructure for 5G and the future 6G, aerial base stations mounted on drones, high altitude platforms, and also satellites for sure at different altitudes, VLEO, LEO, MEO, for very low, medium Earth orbit, and geostationary satellites. So, well, so far, all these technology, satellite systems, are mostly based on proprietary solutions. And the good thing when we try to standardize this technology is that we can bring a lot of network interoperability and also bring a lot of interworking of those different layers of networks. Um, so this is also why this step forward of 3GPP in this ecosystem has really raised a lot of attentions. But obviously, this is not very simple from a technology perspective because each of these layers has its own performance, its own material constraint, and its own maturity in terms of business and also in terms of technologies. And to my mind, what could maybe stop this network of network to go on and to evolve is really how we can transform this technology into a business reality, which use cases we should target, because it's not the same to talk about service ubiquity and also service continuity. And because there is no approach like one architecture fits all use cases, then this has a lot of technical implications. And also, we also have to find the right business organizations to operate these networks, because NTN is essentially worldwide, while terrestrial networks are traditionally managed at a national scale. So we really have to rethink our role of operators, and probably this aspect of business, it's much more tricky compared to the technological aspects. Well, and to my own personal mind, what could stop a network of networks working in practice would be to forget that TN and NTN operators are not exactly peers, even if both could be fully 3GPP compliant.
Brilliant. Thanks very much, Fanny. That was a great introduction. There's obviously plenty to pick up on from what you and Paul have been saying already, and we do have some questions in. But before we do any of that, let me hand over to Dimitris.
Yes. Hello. Thank you, Alex, and thank you, Paul and Fanny, for the introduction. I'm Dimitris Mavrakis. I'm a senior research director with ABI Research. So we are an analyst house specializing in technology research. And I'm in charge of telecom networks research here at ABI, looking at 5G, 6G, NTN, Open RAN, and everything that concerns cellular networks, at least. And my experience with this network of networks topics goes back to my university days when I did a PhD in satellite and mobile communications. And we were discussing hubs back there, so high altitude platforms, and how this could improve connectivity in a city. And I guess since then, there have been many concepts and many discussions around the benefits of these types of networks. But from my perspective, and as an industry analyst, bringing technology and commercial aspects into the same discussion is that everything is a compromise, right? And everything needs to have a balance. And I'll give you an anecdote, an example. So back in the day, before we had small cells in the industry, we had femtocells. So I'm not sure if you remember, but a femtocell was something you could get from your mobile operator. If you didn't have coverage at home, you connected it to the internet and you had coverage at home. And I remember specifically back then that the major technical challenge was that if you were on a call at your home, connected through the femtocell, and you went out of your home, you had to hand over to a macro cell, to a public cell. And that was a monumental technical challenge to solve. It required both a lot of technology expertise and updates and also investment. And at the end of the day, nothing happened, right? There were some proprietary solutions out there, but the question back then was, is it worth it spending all this effort and capital in order to solve this problem that at the end of the day is a niche use case, right? Someone on a call at home going out of the house, right? And we go back to the same discussion now. So this network of networks, what is it trying to solve? What problem is it trying to solve, right? And is it worth the effort of creating a network controller that can control multiple networks, right? So that's the challenge part. However, if we look at the other side, if we have a mobile phone that can connect both to cellular and satellite networks, then we're solving a very big problem. And we already have a few examples where this has saved lives, right? For example, in Hawaii, in the recent wildfires there were people that were stranded without a cellular connection, and they had modern phones, latest generation phones, and these phones connected to satellites to give a distress call, and this phone gave the location of these distressed people to firefighters, and they were saved, their lives were saved, right? So it's not, I think this discussion is certainly not in vain. I mean, there is a lot to improve there, especially for emergency use cases. But the question there are many questions that remain there from a commercial perspective. For example, who will make money out of this? And who will drive the evolution, the deployment, and the coordination of these multiple networks? And at the end of the day, devices do this to a certain perspective. For example, if you go from if you go into your house and your device may automatically switch to Wi-Fi, and then there's continuity, right, through TCP at the base level, right? So all of these questions and research topics are concerning us at the moment here at the ABR Research, and we're trying to understand how both the technical part as well as the commercial part will develop.
Great, thanks, Dimitris, and that's I think a sort of very good summary of at least one of the reasons stopping there already being a network of networks. Of course, if we're looking at something that from an end user perspective just is convenient and reliable, then I suppose that there is a question here about how well, two things leap to mind. I mean, firstly, do we look at this network of network concept more as roaming but on steroids? And in some of the very extreme examples, if we're talking about just making sure that people can connect to a service wherever they happen to be, potentially even through mesh networking back to an access point through other devices. That could be something led by the device. But I wonder then sort of what would the ramifications be in terms of how that's managed, both as a service and commercially. I'm going to sort of start with Paul here and sort of see what your thoughts are on that.
Yeah, well, I think as you're speaking there, and also with what Dimitris has just been mentioning, I think it's also important to think about the levels at which interworking can occur. So we can be thinking about this kind of at the application level, at the core network level, or at the RAN level, like on a course kind of split. And I think that some of those things, like Dimitris said about, is it necessary moving from Wi-Fi to outdoors? If there's continuity of an IP connection and an application can handle that change of routing and carry on as normal, then from the user's perspective, there isn't a sort of a need in that sense for a deeper level of integration into working. So then, yeah, it's the business case then of considering the cost and say for core network level integration, where maybe it's radio access technology agnostic, but you have a little bit like the kind of 5G and WLAN integration. You have some control still from one standard that is managing routing to some degree. But again, whether that's significant enough of a difference in sort of user experience to warrant that over an application level into working over like what I just described. And then I think at the RAN level, it gets harder because at that point you're considering the suitability of different access technologies for different applications. And I think that's where there can be some challenges with, well, for example, like the NTN and TN integration side of things, because trying to design in a universal manner to handle terrestrial scenarios and NTN type scenarios from a radio perspective can be challenging. So maybe kind of there needs to be some divergence there in kind of the radio level, but there can be integration at the core level. But yeah, I think overall it's kind of understanding what level of interworking is really required and yeah, what the business case is for going deeper than application level.
That's fair. Actually, Fanny, I was hoping that you'd be able to comment on this as well, particularly if we're looking at sort of direct to device from non-terrestrial environments. Is that something where, for example, the handset is going to sensibly be able to make a choice about whether to sort of go through that NTN route or a local environment?
Yes, so in terms of interworking, there are lots of different technical solutions. So maybe I will start with just reviewing the main technical solution very briefly, and maybe also have pros and cons. And then we can talk more maybe about some business perspective after. So there is the main possibility is the one which was mentioned by Polaris and which is already existing. That is a device which is able to switch from one type of connectivity, for example, terrestrial network, and another type of connectivity. This is done sometimes by device manufacturers, and they are already existing phones which have dual SIM solutions where you can put some SIMs for terrestrial and some other for satellite communications. So there is also some offers which are proposed by operators for this. For example, here Orange's agreement with Nordnet and Eutelsat OneWeb to bring connectivity for homes and enterprises in places where there is not sufficient terrestrial coverage. So, well, with this, we could say that, okay, this is done. We already have our network of networks. Even if we do not have at all any homogeneity behind, but that's it. We have something which is working. But then the fact is that those basic solutions have, let's say, they cannot really combine the continuity of service, the economy of scale, or the device manufacturing, the one single device and one single radio technologies. And sometimes it may be a bit hard to have evolved use cases, for example, cars or drones. When you have a connected drones with remote piloting, you do not want to have a service interruption of a few minutes once you are flying, because, for example, you are using roaming. So this may be a problem if you are looking on some very specific use cases. So that's also why there have been some other type of solutions which have been proposed about this this interworking of this network of networks. So I was mentioning this integrated device, which integrates capabilities of smartphone and sat phones. I was talking about also roaming, but there is also now more and more the solution of having NTN, which could be operated by the core network of the terrestrial network operator. For example, this is the IST Space Mobile Solutions. So in this case, this is the MNO, which is providing the spectrum for NTN connectivities. And but this question of spectrum is, well, quite hard, especially in terms of regulations and liability and responsibility with regard to this use case. But still, with this roaming or let's say first layer of network interworking with sometimes one core network managing both TN and NTN networks, and other solutions with two core network, one for TN, one for NTN, and then roaming agreement, you cannot offer service continuity. That's why for R&D we are trying to go deeper in this direction. So we have, let's say, two main types of solutions. The first one is multi-connectivity with a converged core network for TN and NTN systems. So the idea is really to take what have been done for Wi-Fi, or more generally for non-3GPP access, and to consider that, okay, this can be done for NTN. The NTN can be this non-3GPP access, and then we try to have something. So this is technology like multipath QUIC and ATSSS for 3GPP and IETF. And at the very end, in terms of homogeneous network, you have the fully integrated TN NTN, which is managed by a single core network and also a single let's say way to perform all the different network functions which are required for TN and NTN. So this is the fully homogeneous network of networks, which is, for example, fully 3GPP compliant. So you manage just one network, whatever it is, TN or NTN. So this is from a technical perspective.
Brilliant, thank you. And I think that sort of really does sort of address maybe sort of one of your points there, Dimitris, about, you know, what the point might be. I mean, if we're looking at something which is, for example, able to sort of perform and meet some specific SLAs, it would be hard to be able to guarantee that over multiple networks. So as we get into some of these issues where we maybe need either more reliable performance or certain quality guarantees, you know, there may need to be something new there. But I guess my question is, you know, in most of the situations that we're talking about, I still do worry about this question of service level agreements, quality of service. We're seeing more adoption of things like 5G in the enterprise, and I know that that's just something that people are looking at more. So, you know, are we looking at maybe sort of having a network of networks where the overall effect of having more coverage and potentially more bandwidth, if we're able to sort of combine performance of let's say 5G, Wi-Fi, and so on, are we looking at a best effort which is better than any one network today, and that's going to be good enough, or do we actually need to look at something that's much more deterministic in nature? And Dimitris, I'm just going to throw that at you because I know you've had a look at sort of some of these issues over the course of your career. It'd be great to get your thoughts.
So if you look at today's landscape, even for these public safety applications on phones, they are provided on a best effort basis, right? Now, if we look at SLAs and quality of service plans by mobile operators, they've been unsuccessful in the past for the reason that operators cannot guarantee coverage, right? So what happens at the cell edge where there's very little coverage and, the signal drops back to 2G, or in underground, or in a building, or in a basement, or in where you don't have coverage, right? So some operators are more successful than others. I think in Singapore, some operators have managed to implement these types of packages, and they have tiered, so silver, gold, and bronze packages for consumers, right? But in most markets, these have failed. So I don't think we will see SLA and QoS plans in mobile, let alone in this network of networks environment, right? It's impossible to guarantee in more than one network, right? Even in one network is difficult, right? But as you say, if we have more coverage and many systems working together in harmony, then perhaps this is good enough, right? This best effort connectivity may be good enough for most applications. But then we have to consider whether the strategic and monetary priorities of these different companies that deploy these networks are aligned, right? And again, going back into to the past, and we have cellular and Wi-Fi, right? So we've had initiatives like Passpoint or Hotspot 2.0 in the past, right? But I mean, if you look today, very few operators, if any, support them. So, and again, it's an alignment of commercial interests that doesn't play well. And at the end of the day, it always boils down to more revenues for parties involved. And the question is, will you or I pay more for this type of service, for ubiquitous connectivity when, for example, connecting to cellular, Wi-Fi, satellite? Will we pay more? That's questionable, right? And that's not something that mobile operators especially can begin to build a new infrastructure, a new platform with, right? Certainly there will be pockets of opportunity, particularly for center enterprise verticals that require this, always on connectivity, and even areas, even countries, right? For example, in the US, if you combine cellular with satellite and you guarantee blanket coverage everywhere, perhaps this is something that sticks, but we cannot assume this will be the same for all countries and all regions and all verticals and everything, right? Which narrows the opportunity and the market size for these solutions considerably. And another point to note is that if we consider service continuity, enabling it becomes exponentially more difficult as you distance yourself from the device, right? Today, we have a form of service continuity in the device. So the device can automatically select which medium is best. But if you want to enable it from the core network, it becomes inherently more complex. Or if you want to enable it from a level above, from the application layer, then it becomes even more complex, right? And at least in our experience, these types of discussions all boil down to a compromise and a balance between revenue opportunity and complexity. And at the moment, it doesn't appear as if there is considerable opportunity there.
That's fine. Thanks, Dimitris.
Yeah, if I may complete what Dimitri said, well, I fully agree on the need to target the one use cases and the one which will be which will help increase and also sustain the revenue, either because it brings a good economy of scale, or because it's a killer application, even if this is for a niche market. And that's why if we want to go further into the conception of this network of network, we absolutely need to target the right use case, to be sure that the design that we arrived at, and also the dimension that we give to these networks, will fit these different targeted use cases. And what makes me a bit more, let's say, optimistic with respect to this need to have service continuity, or maybe the multi-connectivity from the perspective of the network and not only from the perspective of the device, is that unfortunately there are lots of things which cannot be done if this is only the device which chooses the best connectivity. It may work for main, let's say, main use cases, especially in the B2C market. But for more specific use cases, especially use cases in mobility and critical use cases, most of the time the device cannot is not sure which of the connectivity access will be the best one. Maybe for example, the cellular is not good because reaching the SLH, so it will need to switch to another type of connectivity. But maybe this other type of connectivity is working worse. So there is a need in this case always for the device to sense, to continuously sense which is the best connectivity. And for example, there are use cases for drones which can connect both to satellites and to cellular networks, which is working quite well for pipeline inspections, but it's working quite well today because it's always the same trajectory every day, many times per day. So the network, so the device can learn mostly through AI, which is the best connectivity at a given instant where it needs to switch. But this is not always possible when you are on very constrained devices, where you have to decide which radio access you choose without any knowledge of this network, without any information of this network traffic load and coverage, let's say coverage availability, or sometimes even the probability to get the quality of service that you need. And also when you are on let's say very constrained devices like drones, which are very constrained by their battery, the need to sense and to stay connected on both radio access is really a nightmare in terms of weight, size, and battery. So there are some use cases where you really need to have something which is more developed. But then also come the second part of what Dimitri says. It's really about the balance between the investment and the revenue you can get from this. Because for sure, you are not going to deploy a super interworking system which costs a lot of money if behind you can only have very small revenue.
Thanks very much for that. And actually, when we're talking about some of the decisions being made here around how the networks are selected, it kind of ties into some of the things that the audience is asking about. I mean, certainly we've seen with Wi-Fi that there have been rogue hotspots, this kind of thing that have been used to make vulnerabilities and things. So we've got one of the audience asking about how we can ensure security and privacy in this kind of environment with the potential for it to be more interconnected than ever before. I mean, even if we're thinking as well as terrestrial, sort of simple roaming or interworking with, let's say, private networks or other infrastructure where there's sort of maybe a multi-tenant system. It does seem as though there's a lot more scope for potential rogue actors or this kind of thing. So I'd be interested to get the team's thoughts about what kind of privacy challenges you're seeing in the market, or what kind of security challenges, and how we go about addressing some of them, or in fact, if we don't have solutions just yet. I mean, Paul, maybe I can ask you to comment on this first.
Yeah, sure. It's definitely a very, very good point, and an important one that I think in a way we've already seen quite a bit of this crop up in ORAN, actually, through the security kind of working group discussions there, and we've been involved in kind of participating in developing tests for those types of scenarios and testing security. So I think in some ways it's not necessarily unique to a network of network scenario. It's this general sense of you're opening up the attack surfaces more, and you need to then consider anything that is new, that is kind of not a vector that existed previously, that could be something you need to be cautious about or develop a new protocol for. But I think in general, I mean, again, if we refer back to kind of what's been done for non-trusted and trusted access with wireless LAN and 5G, I mean, we have kind of authentication frameworks, EAP, and the appropriate kind of encryptions, TLS, these kind of things that run across the required links and kind of verify the authenticity of access that's being used, and then depending on that determines on how the traffic can be routed, etc. So I think some of these challenges have already been addressed or kind of looked into in the process of making that standard work. But again, nothing's ever like 100% secure, right? So you always have to kind of keep some kind of question marks around things, and certainly investigate where there are any particular sort of new interfaces that are perhaps not as trusted or as well baked in as previous standards have used. So yeah, I think there's definitely some things maybe from the ORAN security testing side of things, and also the previous work done on 5G integration with wireless LAN, which could help in that space.
Thanks. Yeah. And I mean, to what extent, Fanny, is this a challenge sort of from the end-to-end standpoint? Because I think it's almost the other way around there, isn't it? Insofar as there are at the moment a relatively limited number of actors in space, although that seems to be growing. But for you, I guess it's a question of making sure that the traffic that's coming in is trusted and properly identified. Is that more the perspective from your side?
Yeah, actually, this is a very huge challenge for this integrated TNN system about security, and also about all the duties, the responsibilities of MNOs from one side and SNOs on the other side. Well, the regulation is different, and also what each type of operator is supposed to provide is also different, because one is mostly international and the other one is usually managed at the national scale. So there are lots of challenges and questions. Well, I have no answers about how to translate the challenges from one side and from the other side. For example, for terrestrial networks, you have the border management, you have legal interceptions, the emergency call, also privacy and GDPR, because, for example, if you are using some American satellite communication, most of the time your communication will end up in the US through the gateway. So maybe this will not fit some critical use case in Europe. I don't know. So there are lots of things which really need to be aligned, and my impression is that also roaming maybe will be kind of nightmare roaming agreement, because it's already very tricky for the perspective of terrestrial networks. But in the future, for example, if you have roaming agreement between one MNO in a country with a satellite network provider, which is working worldwide, then if you are roaming to other country, you still have the coverage from the satellite. But so what do you use? The terrestrial roaming or the non-terrestrial roaming agreement that already exists in your home network, in your home country? So there are lots of questions which needs to be solved in terms of PLMN responsibilities. For example, is an SNO will it have to reject, for example, UE because it's located in a country where there is already terrestrial coverage? So it should use, let's say, TN to TN roaming agreement, the normal one. So, and how to avoid all these tricky aspects, especially if at the end we have transparent switching between TN and NTN.
That's a really interesting point, and I guess that sort of comes back down to some of these sort of chasing the money again, and so I mean, I think that's something that still needs to be very much worked upon. Just before we move on, I'd like to sort of mention to the audience, Sylvia, I know you've put your hand up a couple of times. If I can ask you to drop a message in the Q&A box, then we will get to answer that. And we've also had a question in which I'm not quite clear on, asking about integrated sensing and communication technology in 6G. I mean, that is maybe a conversation for a different panel, Mohammed. I mean, I'm happy to follow up as much as possible. I mean, my understanding is actually that there are some proprietary solutions out there, even at the moment, through both Wi-Fi and, for example, millimeter wave. But as we move forward with some of the 6G standards, the aim is to create something that's much more comprehensive, standardized, and essentially become a capability, certainly within the mobile networks. I don't want to get too distracted by that, but I will hand over to the panel just in case you have anything else that you'd like to add on this in terms of your understanding.
Yeah, maybe I can jump in just briefly on that one. So I think perhaps with most relation to what we're discussing here, the area of interest I've seen crop up for this type of thing has been related to bistatic kind of radar type scenarios where NTN networks could be the transmitter and the terrestrial nodes on the ground could act as receivers and do some kind of sensing in that regard. So I think that it's very much in a research early TRL type stage, and probably will be something that is maybe studied further as we move into looking at 6G. But I think, yeah, with relation to eyesight, that's the main thing I've seen that kind of ties the NTN and TN together.
No, brilliant. Thanks, Paul. And the other question that we have here, which I think is actually quite interesting, is to what extent, if we're looking at these services, people talk about automation being increasingly significant within the networks over time to make it as simple and as no touch as possible. But if we've got automation or AI, then there is an implication there that it's going to work according to a particular algorithm. And we've seen famously with facial recognition, there are winners and losers from that. Some people get recognized very easily, some don't. And I suppose there's a risk that if we're going to include some kind of AI into this network of networks to steer things, whether that's from the device or the application or the core, then again, that's going to produce some unexpected results. But yeah, I'd be interested to get the panel's thoughts on whether you've had a look at this in the context of this roaming or interoperability between different networks, whether that's terrestrial and non-terrestrial or otherwise.
So I think in these topics, automation is necessary, right? In 6G networks, in coordinating TN with NTN and many others, right? But and in fact, one of the key topics under discussion for 6G is to have native AI, right? Where the network is fully automated with and AI is part of the network. Now, how this happens is not clear at the moment, right? Because now we have distinct and completely separate AI tools, software tools, in different layers of the network, even different vendors, even different pieces of equipment, and many other dimensions. So how all of these come together and elevate the network and offer automation across different domains is not clear, right? But I think the industry is pretty convinced and heading towards a direction that full autonomy is needed. And I guess what the TM Forum calls level 4 or level 5 automation.
Yeah, no, that's true. Sorry, Fanny, I didn't want to interrupt you.
Yeah. I wanted to say that for the TN and TN interworking, there is lots which is which is being done within many different projects. For example, the European project 5G status and 6G and TN, where we are involved in many different partners. So the idea is really to use the same concepts of the ORAN architecture and trying to propose a homogeneity of this of the building of the NTN segment. So trying to reuse the architecture, the way to conceive, especially the functional splits of the GNOT B, which can be partially on board the satellite and partially on the ground segment. So with these concepts taken from the terrestrial network, taken from ORAN, where you can have multi-vendor solutions, the idea is really to go for a better automations, better orchestrations of resources, of very efficient sharing. So there are lots of different algorithms which are under investigations. Some of them are centralized, some of them are decentralized and share between different satellites, or share between ground and space, between terrestrial and non-terrestrial networks. So maybe I can say that these range of possibilities are under investigations. They have, for sure, different pros and cons. Some are very interesting from the perspective of optimization and enhance user experience, but maybe quite hard to be implemented, especially given the satellite payload constraints, which are very different from the terrestrial perspective. But then once again, the question is, after this, once we have the very nice algorithms, how can we translate these and implement them in multi-tenant TNN systems? For example, some algorithms, because they are a bit too centralized, may be a bit harder to work with roaming, where there is not that much network interworking, where there is not that much data exchange to let those algorithms work. But some of these algorithms can be also very nice for other types of business organizations and the technical solutions for sharing. For example, one algorithm, a bit more centralized, can be better for RAN sharing systems. Why not? This is under investigation, so let's see next year or a few years later how it's going.
Yeah, that's brilliant. Thanks. And I mean that does make me sort of wonder, as we're talking about this, whether we're going to be able to train sort of 100 different AIs to operate smoothly together. Somebody asked me this question just last month and put it this way, you know, can we train 100 mice to act like one horse? I think the jury's still out on that at the moment, but we've talked. I realize we're coming up to time, but we've sort of talked about interworking and interoperability a fair bit over the course of this webinar, and I'd be interested to get your thoughts before we round up about, you know, whether this is something where we actually need to rely on a standardization process, simply because I've seen organizations like ORAN Alliance, like the Global ION Forum, things like this, looking at interoperability and interworking. And it seems as though this is kind of the outcome that they're looking for. And if it turns into a standard, brilliant. But just making sure that solutions can happen in practice, in network. And I wonder whether you see that as a way forward here as well, whether we do need to be a bit more pragmatic and develop just, you know, elements that work as we go. And maybe Paul, you know, is that the way forward, or if not, you know, what do you think that way forward should be to get closer to a network of networks in field, if not in practice?
Yeah, I think it goes back to maybe some of the things we opened with discussing around when it's needed and when it isn't, and the, you know, the business and commercial drivers ultimately, because when it comes to standardization drivers, the topics that are going to be favored for kind of development within 3GPP or other bodies are going to be those that predominantly have the most support, because there's seen to be a business driver and you know, applications that will desire it, and there'll be growth at the end of the day from selling equipment and deploying it. So I think that we have to bear that in mind. I don't think that we're going to see a kind of network of networks utopia where everything's connected. A lot of these networks are designed for different purposes. I think some of them could be more integrated than others where it makes sense. And certainly, as kind of Fanny is looking into, and that with the NTN and TN, I think that's the key one right now, which is getting a lot of attention, because we have the opportunity there to maybe have a deeper level of integration through the standards, with 6G ahead, and the fact that we've already done a lot of work in NR. So I think that's a really interesting area, and there could be many applications that come from that. But in general, beyond that, again, you have to ask the question, sort of when is it needed, and when can we do without?
That was actually a really nice summary. I realise we're up to time, so I'm going to just ask you each to sort of flag up one of these challenges. If it's a roadblock that needs solving, where does the priority lie in your view? And then we'll close up. But Fanny, maybe I can start with you and ask, where the biggest challenges are for this in your experience.
Well, a lot of things. Well, first of all, I would say that I do trust technology and R&D. If it's, let's say, only a technical challenge, I think that we'll manage it. But maybe we need also to better understand. Well, maybe talking to other R&D engineers, we need to better understand how far we are from the ideal approach that we are usually having, which sometimes is a bit oversimplified from the perspective of business and multi-tenant solutions, where behind you also have investment and the need to monetize solutions. So how far we are from this ideal approach, if we consider the real world, where there are true borders, not like Europe, you see, when part of data is unknown because it is confidential, or it costs too much, or where there is no, let's say, trusted platform or trusted stakeholders to safely exchange all the information that we need to have something which is very very smooth in terms of interworking and in terms of continuity of service between the different sub-networks of these networks.
Great, thanks. And I'll give Dimitris the last word here. Is there is there a particular roadblock that we need to consider, or is it just kind of the industry being what the industry will be?
Just what Fanny said. If the technical challenges can be worked out, but from past experience in these sort of discussions, identifying the commercial business case needs to come first, right? And if there is a commercial business case and a strong one, then everything will work itself out. We cannot do this through standards, because we need different standards body working together, which is nearly impossible. And then coordinating multiple networks with multiple companies that have deployed them with different strategic priorities is also a very difficult task. But if there is money to be made there, then yes, it could work.
Great, thanks, Dimitris. And with that, we are up to time and a little bit over. So it just remains for me to thank Fanny, Dimitris, and Paul, as well as you, the audience. Remember, we will put this recording on the 6G World website later this week. So if you need a refresher, then you'll be able to find that there. For now, though, all the best to everyone, and goodbye.